So what we're going to look at is what would happen if we were given some type of word problem that involved inequalities. We're going to do the same basic thing that we did when we were doing systems of equations, except now I'm going to use Desmos to help me come up with potential solutions if that's what the question asks me for. So we're going to start by writing our statements, writing what our variables are going to be defined as, and then looking at the graph of Desmos. So we can work no more than 10 hours and we have 2 jobs. This is kind of dinging my head to think might want to be thinking about defining X and Y as my jobs. So I do house cleaning for $5 an hour and a sales job for $8 an hour. And I need to earn at least $56 each week to pay my bills. So our goal is going to be to determine different hours that I could work cleaning houses and at my sales job and still meet both of these requirements. So I'm going to define X as my hours house cleaning. And Y is going to be hours at sales job. So ultimately, I can't work more than 10 hours in a week between my 2 jobs. So that tells me if I add all of the hours that I work together, X plus Y, it cannot be bigger than 10. 10 is the most I can work, so that's where my inequality will be showing. 10 is the greatest. Now I also need to earn at least $56. So if I take the hours I'm cleaning houses and multiply that by 5, this tells me how much money I'll make from cleaning houses. And I'm going to add that to the money I would make at my sales job. And I need this to be a minimum of $56. So 56 is the smallest number I could possibly see. So I'm going to go over to Desmos and I'm going to put those 2 equations in exactly as I wrote them. That would be less than or equal to, oops, it helps if I write less than or equal to 10. And then this 5x plus 8y is going to be greater than or equal to 56. So now I'm going to zoom out a little bit and I'm going to add my step of 1 so that I can see all of my numbers. Now X is hours and Y is hours. So I can't have anything in quadrant 2 or quadrant 3 or quadrant 4. The only quadrant that matters to me because I'm talking about hours is quadrant 1. So this purple hue sliver in quadrant 1, where both of these 2 things overlap, is where I can get potential combinations of hours for house cleaning and hours for sales. So for example, right here, I could work 1 hour cleaning houses and 8 hours at my sales job and meet the requirements for both inequality statements. I could do 2 hours of sales. Nope, that's not true. I could do 2 hours of house cleaning and 7 hours of sales and also meet that requirement. I could do 2 hours of house cleaning and 6 hours of sales and still meet that requirement. I could also, because this is a solid line here, this point right here if I could get right on the nose. It was there for a second. 2 hours cleaning houses and 8 hours on my sales job. And because that line is a solid line and it's equal to, that also meets my requirement. So those are some examples of potential solutions for question number 1. I'm going to do the same thing with these other questions, and I'm going to help you set them up and understand what I might define X and Y as. So here, I need to buy at least 20 candles. I can spend no more than $80, and there are small candles and there are large candles. Right there, it tells me exactly what I should make X and Y, because I need to buy candles, and I can only buy 2 sizes. So this is the number of small ones that I'm going to buy, and the number of large ones we're going to buy. So I have to buy at least 20 candles. If I add the number of small candles I buy and the number of large candles I buy, that has to be a minimum of 20. That means 20 is the smallest number of candles I could buy. But we've only got $80 in our pocket. I can't spend more than I've got. So 3.5 times my small candles, 5 times my large candles, has to be less than or equal to 80, because that's all the money we got. We can't spend more that's in our pocket. We don't have a credit card. We're just going with the cash in our pocket. So these are my 2 statements. Both of these are equal to's. So any in the shaded region that falls on either of these lines that's in that overlapping section would also meet the requirement for Jonah. Moving on to number 3. We're doing a fundraiser for school. I have to sell at least $200 worth of items. We're selling shirts for 10 and hats for 8. And now I have to sell more than 12 hats. So this one is a little bit trickier because I'm not going to have 2 inequalities. That's not true. I am going to have 2 inequalities, but I don't have a necessary definition for shirts. I only have a definition for hats. So we're going to look at what this one will look like on the graph. So I'm going to make X the number of hats. I'm going to make Y the number of shirts. So I have to make this at least $200. So 200 is the small amount. It's the minimum. Shirts are 10. So 10 times Y. Hats are 8. So 8X. Those 2 things added together. This is the amount of money I make off shirts. This is the amount of money I make off hats. And I have to sell at least, nope, that's not true, more than 12 hats. I can't sell exactly 12 hats. That is not going to fly. So if we go back here to Desmos, I'm going to get rid of those 2 from question 1. We've got 10Y plus 8X has to be greater than or equal to 200. And then X has to be greater than 12. I'm going to zoom out here a little bit. So now I have a vertical line and a sloped, slanted line. Anything out here in this ballpark in quadrant 1 will suffice. These points on this line here will suffice because it's solid. This point and all of these points up here will not suffice because it is a dashed line. So 15, 15 would work. This is what, 16, 11, for example, that would work. but anything on this vertical dashed line will not suffice because it is dashed, which means it's not included. Last example here, and for this one I'm just going to do the setup. I'm selling pizzas to raise money for a trip. I have cheese pizzas and pepperoni pizzas. I'm going to stop right there and I'm going to define X and Y. The first one they talked about is cheese, so I'm just going to label this one cheese. Second one they talked about was pepperoni, so this is going to be pepperoni. So I have to sell at least 2 of each kind of pizza. So X has to be greater than or equal to 2. The number of cheese has to be bigger than or at least 2. It's going to be the exact same thing with Y. And now I can worry about my money equation. So $8 for cheese. So 8 times X. $9 for pepperoni. So 9 times Y. And that has to be at least $180. That means it includes $180. If it would be more, that'd be great. We want to make as much money as we can. But if it's exactly 180, that's okay too. Now this is a question where I've got 3 inequalities, but 2 of them are defining what is okay for X and what's okay for just plain Y. So I'm going to just show you very quickly what that would look like. X is greater than or equal to 2. Y is greater than or equal to 2. And then I've also got 8X plus 9Y is greater than or equal to 180. So now I have 3 overlapping areas that I need to worry about, which will now be out here in this space. This point will suffice. This point would also suffice because they're on solid lines. But anything out here is also another stipulation that would work for all 3 of those inequality statements.